Hey, it is lesson number 5 of Unit 14. Woohoo! And today we're going to look about permutations. What on earth is a permutation? Well, we better find out. Okay, basically, how many ways can I arrange members of a set into a sequence or order? Now, we don't have to use every single member of the set. So let's pretend I've got, 10 students and we're going to get into a single file line. Well, if all 10 students are getting that line, well, then I got to use all 10. But maybe only 5 of them are going with the first group, and I got to figure out how many ways I can get 5 of them to line up in a straight line. Right? And order counts here. Right? Repeats are not allowed. So if a student is put in the front of the line, that student cannot be used again. If another student is the second one in line, that student cannot be used again. Or imagine I'm going to eat 3 cookies. If I eat the first cookie, that cookie cannot be eaten a second time, right? It's done. So we're going to start out with a real basic one. I got the letters A, B, C, and I want to be able to arrange them. Now, of course, when I first started doing the probability, we talked about making trees, and we could do that. And so the first letter I could pick A, B, or C. Now, if my first choice is A, when I make my second choice, it'll either be B or C, right? Because I can't use the A again, right? I cannot use a repeat. If my first choice was B, my second choice has to be either A or C. Or if my first choice is C, my second choice has to be either A or B. Now, if my first choice was A, my second choice was B, my third letter has to be C. If the first letter is A and the second letter is C, no choice. The third letter has to be B. Right? And so this tree does not have branches that split in this last section, right? Because I'm not allowed to repeat a letter. Right? So for example, this very last one, if C was the first letter and B was the second, A will have to be the third letter. Now, these trees are fantastic as long as I've got very few items, few members of the set. But what if there are a lot of members of the set? Right? Is there some other way I could have said, hey, look, there's 6 ways of doing this? Right? Time consuming, use up a lot of space on paper, especially when I start getting into larger sets. Well, could make a list. Right? There's 6 different ways. The problem with this, though, is that I sometimes miss a member. Right? So it's like, hey, there's 6 different ways. What if I don't necessarily catch them all? It's also a little trickier, too, to make sure I don't accidentally repeat something. Oh boy, grammar, please just bust me there. If there few items, how about if there are few items? Oh boy, we'll have to fix that side. But yeah, so the tree or the list will work fine as long as there are very few items in the list. So the easiest of the bunch is going to be multiplying. Right? 3 choices for the first letter, 2 choices for the second letter, 1 choice for the third letter, 3 times 2 times 1 makes 6, right? That'll be the easiest, most concise way of doing this. Instead of making a tree or trying to make the list, just say, hey, 3 times 2 times 1 is 6. So let's pretend that we've got a little preschool here. I've got 6 wonderful little individuals running around. Of course, I used A, B, C, D, E, and F as the first letter of the name, so it's a little bit easier to keep track of them. And it's going to be playtime, right? And they have to get in a straight line. Maybe they even have to each hold onto a rope as they go out. But they have to get in a straight line to go out for playtime. How many ways can they line up? Well, this is going to get pretty big. Trees can get very large. A list, do you think I'd really be able to get every single possibility in my list, every permutation? So if I just want to know how many ways, multiplication is going to be the best. Any one of those 6 students could be first. Once that student is first in line, though, we will not reuse that student. So there are 5 students that could be second. Once we have the second student in place, now there are only 4 students that could be in third place. And then only 3 students for fourth place, 2 students for fifth place. And then once 5 students are in line, there's only 1 student put at the end. 6 times 4 times 3 times 2 times 1 is 720. Imagine what a tree would look like with 720 branches at the end. Or imagine trying to make a list of all 720 permutations. Yeah, you could do it, but you'd probably go cuckoo for Cocoa Puffs as you went along. And the chance that you did all of them correctly, well, I know I probably wouldn't. I would probably mess up. Right? The tree or the list, it would be frustrating. And it would be time consuming. And especially with trying to list the possibilities, good chance of making a mistake. So, your good friend here is going to be multiplication. Okay, so I'm going to go to an ice cream parlor. Ooh, chocolate ice cream, vanilla ice cream, strawberry ice cream, Rocky Road, Spam ice cream, Spam, and orange. Of course, the orange is probably a sorbet or a sherbet instead of ice cream, but you never know, it could be orange ice cream. Hey, they got a special. You pick any 2 different flavors and you stack them on an ice cream cone. Now, order matters, right? Because on an ice cream cone, you got the scoop on the bottom, scoop on the top. And most of us, when we start licking an ice cream cone, we start with the scoop that's on top. So you'll finish that one first, and then you'll get to the other one a little bit later. I mean, yeah, you can kind of go on the side, but it's a different experience, right? Whether or not one of the flavors is on top or on bottom. So the order matters when I'm putting them on an ice cream cone. And of course, the daily special says, hey, you got to use 2 different flavors. So now, most of us might say, hey, if my favorite's strawberry, I want 2 scoops of strawberry. Well, that's not how the special works, right? So if my favorite is strawberry, I might put that on first. And then, I don't know, maybe I'll pick Spam as my second flavor, or Rocky Road, or something else. So how many permutations are possible? Well, it looks like there are 6 flavors. Right? Almost got to do that counting first. I'm counting 6. Right? Rocky Road is 2 words, but it's only 1 flavor of ice cream. So I've got 6 different flavors to choose from on the first scoop. and then 5 different choices for a second scoop. But then I'm done. Unlike the 6 preschool students where we did 6 times 5 times 4 times 3 times 2 times 1, here I just do 6 times 5 because I only have 2 scoops here for this special. All right, 6 times 5 is 30. All right, so you're going to have some fun with the IXL today. You'll actually be working with permutations. All right, so the IXL will be X5. It'll be permutations. And it looks like you got a bunch of super cats to help you out.